we will only work on the products. We will do the segmentation based on the product usage. We will do the segmentation based on the product usage. Fresh milk, grocery, frozen, detergents, paper, and delicacy. Okay, we will eliminate the channel and region for the time being because they are categorical variables, right? Rest of all are numeric variables. Channel and region are categorical. Not that you don't need, you can't include categorical here, but we want to segment customer based on the product usage. Segmentation of the customers based on the usage of products. Segmentation of customers based on product usage. So we will eliminate channel and region. Sale data is equal to wholesale data dot drop open bracket square bracket single quote channel comma single quote region comma axis is equal to 1. Axis is equal to 1 is column dropping. We are converting the data into, we are only doing the segmentation on product usage. All right. Okay. Now, like I told you, all distance-based methods, you have to do scaling or normalization. We will implement standard scaler. Okay. From sklearn dot pre-processing import standard scaler. Scaler is equal to, scaler is equal to standard scaler null brackets. Sale data scaled is equal to sale data dot apply scaler dot fit underscore transform. Okay. Scaler dot fit underscore transform sale data. Sale data scale is equal to scalar dot fit underscore transform sale data. Sale data scale dot head. Okay, we need dot data frame. Columns equal to data dot columns. So this is our transformed data. This is our transformed data. All of you got the data till this point? Scaling of data, standard scalar, x minus mean divided by standard deviation. Okay. Now, the k value has to be assumed. We don't know the exact value of k. We have to assume. So there is one method of randomly using k values and then calculating the Silhouette score. Silhouette score will tell you whether the cluster formation is good or bad. Silhouette score lies between 0 to 1. Silhouette score closer to 1 means the clusters are clearly separated. Silhouette score closer to 0.50 means the clusters are separated, but they are very close, might be touching. If it is closer to 0, let's say 0.10 and 0.20 indicates overlapping. If Silhouette score is negative, that means it's a failed, complete overlapping of data. So based on Silhouette score, we will decide whether the cluster formation is good or bad. Typically, we want it to be above 0.50 as much as possible. That way, we can have a clear cluster formation without any overlapping. Now, there are two methods, like I told you, to randomly choose a k value and then do it that way. Or we can write a loop with the different cluster values from 1 to 10, 1 to 15 like that, and then find the best k value based on the elbow point where we are getting this scree plot, and then we can do it. So let us do a scree plot and then we will find the clusters. Okay. So all of you have scaled the data from sklearn dot cluster import k-means. From sklearn dot cluster import k-means. Now, one of the metric is WCSS. Within cluster, the full form of WCSS is, I forgot, 1 second. Within cluster sum of squares. WCS is called as within cluster sum of square distance each point and the centroid in the cluster, WCSS. This is the one of the metric, WCSS. So we will calculate WCSS is equal to null braces. WCSS is equal to null braces. Then for I in range of 1, 10 colon k means is equal to k means in bracket I, k means dot fit of x x is capital, na? We have not given x value here, right? What is our data? Sale data scaled. AS is sale data scaled. WCSS underscore iter is equal to k means dot inertia WCSS dot append WCSS underscore iter. So num underscore clusters is equal to range 1, 10 plt dot plot num underscore clusters comma wcss plt dot title elbow plot plt dot x label is number of clusters, plt dot y label is wcss plt dot show. We will reduce it to 7, then we might get a clear plot. We got 2 elbow points here, right? I think 5 we will take. 5 will be better, right? Or we'll take 2. We got 2 elbow points here. But there is a big difference from 2 to 5. 5 to 6 and afterwards, it is the change is not that great. You can see here. 5 would be better option, right? No, 5 is the bent. Yeah, but 2 clear points is 2 and 5. We'll build 2 and 5 and see which has the highest slope score. And then we'll decide, right? That's what I wrote it now, yeah. WCS is, sorry. Within cluster sum of square. Within cluster sum of square. Okay, now let us build the model. A 5-cluster model we will build. So cluster 5 model is equal to A means n underscore clusters is equal to 5. Plus 5 model is equal to plus 5 model dot fit fail data. Okay. So we got the cluster centers for different points. So np dot round so for the first cluster, these are the individual center. Cluster 1, for each variable, this is the centroid. We have given 5 clusters, right? And then we have 5, how many columns are there? Not 5, 1, 2, 3, 6 columns. So cluster 1 for 6 variables, these are the 6 cluster centroids. This is the second this thing. So cluster 5 model dot clusters is not predicted. No. Fail data scale square bracket single quote cluster num is equal to classify model dot predict sale data scaled. What happened here? Only integer slices, new axis, and integer booleans are valid indices. What is the prediction? Yeah. Labels is already predicted, right? We have already the labels, right? Labels is already there. So we don't need to predict or forecast. So sale data scaled square bracket number of cluster number is equal to classify model dot labels. What is this? Okay. So classic mistake. Sale data scaled is equal to pd dot data frame sale data scale comma columns is equal to wholesale data or sorry sale data dot columns. Okay, now we have converted into sale data scale square bracket single quote cluster number is equal to classify model dot labels. Now we got the clusters. So sale data scale dot head. That's the cluster number 4. So the first observation will fall in cluster 4, cluster 1, cluster 0. Like that, we got cluster 4. So we can do the value dot cluster number. Sorry, I gave space here. That's a rookie mistake. So 270 observations in cluster 4, 96 in cluster 1, 63 in cluster 0, 10 in cluster 2, 3 in cluster 1. From sklearn dot metrics import out score. Out underscore score sale data scale comma classify model dot labels. We got sell out score of 0.58. 0.58. So for sell out score, so intra-cluster distance is calculated. Similarly, the best value is 1, worst value is interpretation of the Silhouette score. So 0.58 we got for 5 cluster model. How come you got less than 0.5? Build a 2 cluster model also and see whether your Silhouette score improved or not. 2 cluster model. Same we got, huh? For two clusters, huh? That means 2 is the better option. 73 or 43?
97.
You can't have such huge difference. Check. +2 model is equal to K means underscore clusters is equal to 2 +2 model is equal to +2 model dot fit scale data scale dot score scale data scale comma +2 model dot labels 0.54 I got marginal difference. Right? So cluster 5 cluster model is better than 2 cluster model. 5 cluster model is better. You have to use the right labels. Sale data scale is equal to sale data scale. Oh, sorry, sale data. Only the labels of the which cluster number they belong to. Each observation is assigned a cluster number. They are the class 0 to 5 cluster numbers will be assigned to the each observation. Which observation falls under which cluster? Sale data scale df is equal to sale data scale df is equal to sale data scale df dot drop single quote cluster number axis is equal to 1. Sale data scale df square bracket single quote region wholesale data dot. How many regions we have? Only 3. Channel also 2. So on this data, we can't do hierarchical clustering. Hierarchical clustering, you have to do it on a different data. From sklearn dot dataset import You all have that empty cast data set, right? No, we don't have in used car sales a categorical variable which will help us to do it properly. Because.csv, I have these files. Documents. Where is it location? File. So, data sets only it is showing bank data sets. Okay. The cars is equal to pd dot read underscore csv empty cars dot csv. Oh, what happened? No such file or directory. Assets. Bank. Why am I not having empty card CSV somewhere? The hell? File. Save. Data sets. Data sets. Desktop. Save. File. Correct. File. Export to CSV. Table names. Next. Desktop. Export. Okay. I'll move this to data sets and I'll go back. I'll remove the bank. Data sets are given, no? Where did it go? I put it in data. Okay, I got the empty cards data. So from sklearn dot cluster import hierarchical clustering. Or agglomerative clustering. Agglomerative clustering. Hclust is equal to agglomerative clustering n underscore clusters is equal to 5. So distance is Euclidean. Linkage is ward linkage. You can use other also. Linkage can be complete average single ward. Okay. Hclust model is equal to Hclust dot fit empty cars. What happened? Oh. String to float, it's not converting. Let's just see what we have in empty cards. Dot head. We have model. Okay. Learn dot pre-processing label encoder. Cards dot model is equal to label encoder dot fit underscore transform empty cars dot model. From sklearn dot cluster dot hierarchy don't have a dendrogram model. Acha, SciPy dot cluster. Cars 1 to 32. So these are the cluster dendrogram for different cars. Single linkage.
Technique is by cutting down the dendrogram from a level, we can find out the K value, right?
Yeah, we can find.
How to like what is like in non-hierarchical, we are assigned. And screen now we are getting the list. But in hierarchical, after forming the single cluster, after forming the dendrogram, from the dendrogram we are getting the hierarchy.
Actually, in R we have that function. Rectangle class will give you the cluster which you want.
Yes.
Here we have to write a loop. Actually, we have to write a loop like this type of loop. You have to write. Whatever.
Observation only we are cutting down the dendrogram.
Let me see once. So for the 5 clusters, we can get the empty cars cluster allocation. Which cluster will fall under this one? If you want, you can add here empty cars square bracket single floor cluster is equal to X plus model dot labels. So we will know which car falls under which category. Empty cars dot head. So we will know the cluster of. So the first 2 cars will fall under cluster 1. First 3 cars. Then 2, 0 like that. We have the cluster assignments. You can find the clusters. Or you can use it for dendrogram, SciPy dot cluster dot hierarchy linkage, and then empty car single. Give the orientation, and you'll get the linkage. Yeah. 1 second. 1 second. So Silhout score is empty cars comma h plus model dot labels 47. This is not a 5 clusters is not a best cluster model. So we can
How to find that?
the cluster model. The cluster master is the better option. So you can do a loop actually. Fill out scores, append, and then you have to fit them, predict them, and then do it. You can do principal components and then do it. That would be, we'll get a different graphs and all. So here it says, to determine the optimal number of clusters by visualizing the data, imagine all the horizontal lines as being completely horizontal. And then after calculating the maximum distance between any two horizontal lines, draw a horizontal line in the maximum distance calculated. So if you draw a maximum distance calculated for all horizontal lines, I think this will be the point. Here you'll draw a line.
There are only 2 clusters.
Then only 2 clusters will be formed.
How to remove that exact horizontal. It's here 30 is the final cluster, sir. All the subclusters are combining 30.
Okay, for wholesale data only we can do. For the wholesale data, we have the scaled data, right? Say scaled data DF2 that we can do. So this is for the wholesale data. Okay. Import scipy dot from scipy dot cluster dot hierarchy import shc. No. Import as hs. Forget. Okay, import scipy.cluster as shc, right? So here it is saying plt dot figure fixed size is equal to 10 comma 5 plt dot title endogram, then dend is equal to shc dot dendogram shc dot linkage bracket sale data scaled df comma method is equal to what? हेलो रिसेप्शन में दे दो, थर्ड फ्लोर रिसेप्शन में दे दो. Okay, this is the dendrogram we got. Now, if you want to draw X line, if I want to draw a line, I think I can draw that line 35 not, right? It has to be somewhere around 30. So PLT dot AX H line y is equal to 30 comma color is equal to R. This is right, you can draw a line. Because that is about the cut, right? About the cuts, this is the thing, na? Maximum line about the cut from the where the dendrograms are forming. Or let us see if we can PLT dot scatter sale data scale df square bracket single quote milk comma sale data scale df square bracket single grocery comma C is equal to SHC dot. No. We have not given the name the model, right? H class model dot labels. Oh, sorry. This is what best we can find based on the H cluster stack abuse. The longest vertical distance without any horizontal line passing through is selected and a horizontal line is drawn through it. The number of vertical lines, this newly created horizontal line is equal to the number of clusters. So he is saying clusters will be 2. The horizontal line cutting above all the horizontal lines. The horizontal line drawn above all the horizontal lines. So this is the 38 is the thing. So we can have maximum 2 clusters.
So whenever the cluster is forming, before that,
Afterwards. Ab line, yeah, axis line has to be done afterwards. This is not before, right? This is done after. After identifying the point A where the horizontal lines are ending, that is the point where you have to draw the line. Hmm? This is that empty cards thing, right?
For the model, we are getting it at the dot model.
That's what now you have to label and code it, no? Label and code. Model is model name, right?
No attribute is model.
And then for your data, it might not be there because I have converted it from numbers to this thing, right? In original CSV, you will not get it. Remove the model. Don't label and code. Model is on the row index. Check this file once, head. Instead of row indexing, you will have the car names. Right? Empty cars dot head. Unnamed is your that one. Instead of model, you have to use unnamed.
Unnamed, zero.
That one you have to use. There you have the car names, right? That you have to label and code, not the model. Here it created the name model. In your case, it is unnamed zero. Copy paste that column name.
So we have to give that a name.
Which one?
Name.
Unnamed, there you copy correctly from there.
Yes.
Column, there is this space and all. Copy paste the column name from top. Don't type. Don't type. Copy paste the column name from the head output. Copy paste it correctly. Right? You have to copy paste the name. Don't type. You know, you have to import now from sklearn. Where did I import it? I deleted it. You have to import it from sklearn.cluster, import agglomerative clustering. Somehow I deleted that command. From sklearn.cluster, import agglomerative, type capital A and tab, it will fill. From sklearn.cluster, import A, capital A, and then type tab, it will automatically fill. That before, I forgot it actually. I deleted it. So from sklearn.cluster, import A, agglomerative cluster, and then do the cluster. Hello. Yeah, good afternoon. Hello. No interest. First only, we have implemented. You don't need to do it again. Not required.
Correct.